All right, let's dive right into this explainer. We're unpacking the monumental realities of actually sending human beings to Mars. You know, we hear so much about the monster rockets and those incredible engineering marvels being built out in California, but today, we're moving way beyond just the hardware. We're going to look closely at the human software.
We have to start with that bold, almost romantic vision of settling a cold, rocky planet 55 million kilometers away. As volunteer Sue Ann Payan perfectly captures here, the idea of creating a colony off our planet and completely starting a new timeline for human history is, well, it's undeniably amazing. It's a vision driven by pure, intrinsic human curiosity. Honestly, it's the exact same drive that pushed early explorers to cross uncharted ocean.
But that brings us to the ultimate hurdle. This question right here forces us to pivot our focus away from the shiny launch pads and stare directly at the gritty, brutal realities of deep space survival. Because yeah, we can build the rocket, absolutely. But can the fragile human body and mind actually survive this unprecedented journey? That's the real question. So, to really understand this, we're going to map out the journey ahead across 6 main pillars. First, the call to Mars. Second, the psychological toll. Third, surviving the physical threats. Fourth, engineering the journey. Fifth, the benefits for planet Earth. And finally, the ultimate destination. Okay, part 1, the call to Mars. Leaving the cradle. Let's just look at the stark contrast between our protective cradle and the frontier. On one side, we have Earth. It's fertile, 3/4 covered by water, full of lush forests pumping out oxygen, and wrapped in this beautiful protective magnetic shield. On the other side, the completely alien reality of the Martian surface. It is covered in toxic regolith, literally toxic soil. It's bitterly cold, dry, constantly bombarded by deadly cosmic radiation, and it's so far away that real-time communication with Earth is physically impossible. You are truly on your own.
Moving into part 2, the psychological toll, the mind in isolation.
We really have to examine the immense psychological weight of placing highly skilled individuals so far beyond Earth. Because remember, before you even step foot on that toxic soil, you gotta survive the transit. Cultural anthropologist Jack Studer grounds this abstract concept perfectly with what he calls the motorhome analogy. Just imagine getting into an RV with 4 other people and driving around the country for 6 to 9 months, but all the windows are blacked out. You can't step outside. Then, you finally reach your destination, but you have to live inside a confined cabin for 18 months, only venturing out in a bulky, restrictive suit. And then, you get right back in that exact same motorhome for another 6 to 9 month drive with those exact same people. It is mind-boggling confinement.
To really grasp how dangerous this is, we often compare it to extreme underwater exploration, right? Living in a submarine or an Antarctic base. Both of those require intense team isolation in enclosed, small spaces, and you absolutely need high conflict resolution skills. But here's the crucial difference. If something goes catastrophically wrong underwater, you can often still surface or abort the mission relatively quickly. In deep space, you're taking all those submarine-level pressures and adding the terrifying realities of microgravity, deadly solar radiation, and absolutely zero real-time communication. There's no immediate escape route. Plus, you have to endure the profound psychological impact of watching Earth, literally your entire world, everyone you've ever known, disappear into a tiny blue dot in the rearview mirror. It's underwater isolation on absolute steroids.
So what kind of person can actually survive that? As Studer points out here, technical skill just isn't enough. You need an unbelievable level of teamwork, patience, emotional control, tolerance, affability, and confidence. You essentially need the ultimate team player who literally will not crack under pressure. But try maintaining all those perfect personality traits against these extreme, everyday stressors. Did you know that on the International Space Station, the #1 cause of stress is unrealistic schedules? Because everything takes longer in microgravity. Literally taking a bag of M&Ms and sorting them by color takes 5 minutes down here, but 30 agonizing minutes in space. Now combine that constant nagging frustration with less than 20 square meters of living space, the never-ending hum of mechanical noise, eating freeze-dried food, and zero access to normal Earth comforts like just taking a walk in the park or seeing your family. It's a cascading sequence of psychological pressure cooker events. All right, section 3, surviving the physical threats. The biology of deep space. The harsh truth is, our biology simply wasn't designed for the stars. Taking on the conditions of space essentially mimics a rapid aging process on Earth. Without gravity, bones rapidly lose mineral density and muscles atrophy, which demands like 3 hours of vigorous exercise every single day just to survive. Your cardiovascular system goes haywire as body fluids shift upwards, altering red blood cell counts. Amazingly, your skeleton actually stretches. The spine elongates by 1 to 3 centimeters. And neurologically, your brain literally begins to process information differently as those shifting fluids press against your cranial cavity. It is intense.
But the biggest physical risk by far, charged solar particles. See, Earth's magnetosphere is our invisible planetary shield. But once you leave low Earth orbit and punch through that shield, humans have absolutely zero natural protection from cosmic radiation. Our skeletons are on the inside of our bodies, leaving all our cells totally exposed to the universe's most dangerous energy.
Which brings us to Section 4, Engineering the Journey, Hardware for Survival.
So how do we protect them from all this? Well, you build an autonomous survival pod. The Orion spacecraft uses this incredibly layered, backup-heavy design engineered specifically for those deep space rigors we just talked about. Right at the top, you've got the launch support system, ready for an emergency separation if things go south. Below that is the crew capsule, heavily shielded from heat and radiation. Then the service module, which provides the literal breath of life, your propulsion, power, breathable gases, and liquids. And finally, the adapter connecting it all. It's designed to minimize human error while surviving an incredibly hostile environment.
But before we just shoot straight for Mars, scientists propose testing these engineering concepts and human endurance limits a bit closer to home. Enter the Deep Space Gateway. This is a theoretical intermediate station orbiting the moon. It basically acts as a staging post, but more importantly, as a vital experimental laboratory. We need to see exactly what deep space does to a crew for extended periods before we commit them to a multi-year transit with no turning back.
Let's move to Section 5, Benefits for Planet Earth, the trillion-dollar spin-off.
Now, you might be wondering, why does this matter back home? Why spend all this money? Well, look at this number, $45 billion. That is the staggering annual cost to society for broken hips in North America alone. Just to put that into perspective for you, that is more than twice NASA's entire annual budget. Let that sink in.
The point is, if we can solve bone density loss and muscle atrophy to keep astronauts alive on Mars, we inherently solve massive issues for our aging population right here on Earth. This isn't just theoretical. Space researchers are already using hypogravity simulators, which were originally meant for Mars training, to rehabilitate stroke victims. They're unlocking pharmaceutical solutions for bone demineralization and osteoporosis. Space agencies literally hold the largest collection of human physiological data on the planet. The medical spin-offs from trying to survive Mars could completely revolutionize the way we age on Earth. Finally, Section 6, the ultimate destination, shifting priorities. Let's step back and look at the broader picture. Going to Mars isn't just about exploring a new hill. While the red planet is a huge draw, we're also building these monster rockets because we face a hidden, persistent threat: near-Earth asteroids. Seriously, every single month, a new asteroid is discovered passing right between the orbit of the Moon and Earth. They pose a very real, existential risk to our planet, and we urgently need these deep space capabilities to learn how to defend ourselves. So I'm going to leave you with this final provocative thought. Mars easily attracts our attention, right? The romantic idea of becoming a multiplanetary species is incredibly powerful. But do the near-Earth asteroids actually demand our attention? Humanity is exploring further and faster than ever before. But we really have to ask ourselves, is our true priority colonizing a new world, or using this incredible new technology to protect the only home we currently